Hello everyone, this is Dilleswara Rao from Aeronautical department. So, last few classes we are discussing on automatic control of aircraft lectures only. So, previous classes we discussed on flight path stabilization and glide slope coupling. Also, we discussed on last few classes. So, after that, today we will discuss on this gyro sensors and vertical gyro autopilot system also we will take down now. So gyro sensors and gyro's instrumentation is a very essential thing used for aircraft controlling. So because why this gyro sensor is so much interesting is, I mean, if you see why this gyro system is so much interesting is, uh, gyro system is so much interesting is, so we know that our gyro system generally used for small sensitivity thing, like sensitive things if you want to make it out. So that small sensitive movement also it will capture out, so that that captured movement will be transferred to that control surface, and then the aircraft controlling we will controlling can be in the hand only. So the gyro sensors and gyro instrument, I think that mechanical arrangement of gyro instrument you have already seen. So with this, by you taking that input of that gyro system, how this gyro system autopilot is been constructed, and how that gyro instrument calibration also did with in the sense of controlling surfaces, and how it has been carried out also. I've continued. I will show you now. So let us see to the topic. So see, for some autopilot configurations as discussed previously. So it is necessary to determine the actual pitch altitude of the aircraft. So that can be accomplished by vertical gyro only, because the gyro itself you will see, like you see that figure. So this is like a gyro sensor, I mean gyro instrument. So here you're having every axis, like every axis if you are seeing now. So this is vertical axis, horizontal axis, and pitching axis. So this axis will be that whenever the movement is happening onto that one, like if the movement is there here now. So if it is a gyro instrument, so like this and like this also, if three axis system will be placed like that. So when a small movement is given to this one, so that movement will be captured by that sensor, and that will be given to the given as input to that control surface, so that control surface will be operated easily. So in this way, general the gyro system, how every axis will be movable axis only. So in the gyro instrument, if you see here, every axis is a movable axis. So whenever a small disturbance is given to that one, that disturbance will be carried out to that control surface. So here you see there is a three axis system is there. No, one axis is for pitching, and then one is for rolling, and one is for vertical movement. So vertical movements means like yawing movement also will be there, you can take. So the pitching movement will be with respect to that y-axis. So suppose the aircraft is like this. So aircraft is like this. So this axis will be the pitching moment axis. So according to that axis, it will move. So that will be pitching axis, and the rolling axis will be this will be like fuselage axis. So fuselage axis, that rolling moment will be there, and yawing moment also, you know. So these, according to that only, some virtual arrangement will be given to that gyro thing, like according to this axis, so that same like a virtual or some scale down model of, you can say like a scale down model of a total aircraft thing will be given you as a an instrument. So that instrument is called as a gyro instrument. So on that gyro instrument, if that degrees of freedom also will be like 6 degrees of freedom only will be there for that one. So everywhere that gyro sensor will be very accurately calibrated, so that it will gives you a very accurate moment for the moment to that axis also. So here you see for an autopilot, so if you need to, I mean, previously we have given that displacement autopilot in vertical gyro direction. So for that displacement autopilot, if it is altitude control is there. So for that altitude control also, that pitch altitude will be given by autopilot, and that autopilot is being totally depend on that rate gyro system only. That rate gyro system means what? This type of gyro instrumentation, gyro instrument inputs only. So that gyro instrument only will gives you that feedback to that thing, so that it will take that feedback, and then it will gives you the I mean, it will gives you the accordingly on that input only it will gives you the moment. So here that vertical gyro also provides a indication of bank angle for use of conjunction with lateral autopilots also, like this vertical while vertical autopilot means what? When that altitude is getting increasing, the altitude is increasing, so that the vertical gyro only will take care of that input, and so that will be compensate with, I mean, that will be in collaboration with lateral autopilots also it will be there. So the vertical gyro is basically 2 degrees of freedom. That 2 degrees of freedom gyro is constructed so that the angular movement of in vectorial direction is along the vertical axis only. Like the vertical movement along that vertical axis will be, if it is an angular movement, I mean, there's a small that is like a 2 degrees of freedom, like maybe upper, maybe down. So that 2 degrees of freedom will be connected with that vertical gyro instrument only. So the thing you see, there is the two gimbal axes are then aligned, so that the roll axis is horizontal and lies on the XY plane of the aircraft, and the pitch axis is parallel to Y axis. So that has been illustrated actually seen here. No, the roll axis and pitch axis is according to X and Y axis. So this is horizontal will be that H axis will be that vertical thing. So around that. That movement is there, no, that omega will gives you the movement around that vertical axis. So due to its gyroscopic action, the spinning of that gyro tends to remain the non-rotating with respect to that inertial space, or to so-called fixed stars. Like fixed stars means what? That fixed reference agent only. With respect to that reference agent only, that reference line only, these things will be designed. So our reference line is what? That body axis system. So accordingly, that body axis system only, total gyro system will be designed. So see here, this is a thing. So here, to maintain the spinning axis vertical, that is spinning axis means what? Maybe that rolling or pitching, the everywhere that the spinning axis will be there. So if it is a spinning around the vertical axis, so that will be designed in such a way that the suitable torque must be applied to that precise gyro only. That precise gyro means what? That incalibrated gyro system. So this torque will be applied about that pitch axis to precise the gyro about that roll axis. So I mean the torque will be given to that precise axis of roll axis, and then about that roll axis for precision about pitching axis in obedience with the law of gyro only. I mean, once you give one movement to that one, like here you see that pitching axis is been I mean, there will be see, instrument won't be float in the air, it should be fixed to somewhere. So that fixing angle fixing thing is given here only. So that fixing thing is given here. So that means that pitching axis is been that according to that pitching axis, there is a fixed point to that whole instrument. On that only the instrument will be placed. Accordingly, on that you call it as a bed. On that bed, on that bed, it will be like a even inside that instrument also, if you imagine, so everything will be virtually, everything will be moving internally. So if you imagine that, so if it is fixed on bed also, inside that it is floating on some floating on some air type of medium only. So that means there everywhere it is moving according to that axis system only. So here you see the torque will be applied to that pitching axis. That means that the torque is applied to pitching axis to process the gyro about that roll axis. That means if torque is given to that pitching axis, then that thing will be given to that roll axis also. Roll axis also will rotate about that one. So the roll axis, and about roll axis for precision about the pitch axis in obedience with the law of gyro only. So to precise the spinning axis of gyro into an intelligent in alignment with the vertical, that is what the indirection indicated with the plumb bob, whose pivot is stationary with respect to earth. That this is the plumb, that is a plumb bob. So that is actually fixed with earth only. That earth means what? That aircraft base. So which will pivot. Whose pivot is stationary with respect to that earth only. That pivoting point is stationary with earth, but the remaining things are all changing only. So commonly referred as erection, erection thing. So there must be some method of detecting the misalignment and then generating the required torque only. Like misalignment is given to that one, so there it will generate the required torque. Such a method requires some form of pendulous or acceleration sensitive device. So because if it is giving a small thing to that one, means what, there will be a very sensitive movement to that one. So that when if you are giving that input, that is one thing, but taking that input as a taking that input as a command also, that accurate sensors also should be there. So accurate sensor, I mean, previously in olden days, what is this? There is no sensor, so that mechanical movement only will takes you to that control system. So some small movement is given to this one, means that movement will be given, that movement it will take from that pressure, it will take, and accordingly that it will move. Like see in your indicator there is a small movement only, but that small movement only will gives you large output only. So like that here also, that movement giving to that instrument should be very accurate, and while taking that input also, it should be very accurate on working only. So as these devices are incapable of distinguishing between acceleration caused by that vertical vehicle motion, that is a kinematic acceleration, and the acceleration of gravity. So that vertical gyro attempts to align its spin axis in direction of total acceleration, like that is vertical vector sum of kinetic and gravitational acceleration. So usually that will be preferred as a apparent vertical thing only. So if the kinematic acceleration is random, like kinematic acceleration is while we are giving that input in a random thing, so such atmospheric turbulence with a zero average, then due to the slow erection rates, like changing from 2 to 6 degree per minute. I mean per minute 2 degree movement we are giving, means, so that is a slow erection type of things only. So the average direction of spin axis will be aligned with the direction of vertical only. I mean that average direction of spin axis, like spin axis is that what that around vertical. That spin axis will align with the direction of vertical thing only. I mean slowly it is getting, means it is being aligned with that vertical axis only. So however, during the periods of sustained horizontal acceleration, that is the takeoff landing acceleration from a subsonic to supersonic, or lateral acceleration also, the gyro tends to erect to a false vertical only. While the lateral acceleration is suddenly given means that the gyro will erect to a false vertical axis only. So as the autopilot is not generally engaged during the takeoff or landing, so there is no problem encountered here. So however, the autopilot may be engaged during acceleration from subsonic to supersonic flight and back again, so that the resulting misalignment would cause an error in pitch altitude. So the behavior of vertical gyro during the sustained turn is much more complicated than in the case of sustained longitudinal acceleration. So for a coordinate turn, the lift vector is normal to the plane of wings only. That if you see in figure 2, so that how this gyro system autopilot is being designed. So here you see that pilot rudder input. Suppose the rudder input is given to that one. So there is a summing amplifier will be there. So after that summing amplifier, there is a rudder servo and a washout circuit and IARE gyro. This you see it in that autopilot design only. While we are telling about that autopilot system, that displacement autopilot, acceleration autopilot, pitch acceleration and pitch rate gyro system also. Have you discussed on that? There only we have seen this one. So there that rudder servo will be given that input to that aircraft control system, and there will be a feedback from that IARE gyro. That IARE gyro means once this IARE gyro will take you, once that output is off means it will take that gyro as red gyro system as a feedback thing only. Once that thing is open, once that maximum limit is over, so that you can have to stop your signal. So like that feedback it will take, and that will be given to that summing amplifier only. Also that lateral accelerometer feedback also it will give. Once you given that enough acceleration, it has to give that back signal only. That is feedback signal. So that feedback signal will take it out from that acceleration lateral accelerometer, and it will get fed up to that summing amplifier. So here the gyro is then consider the direction of vertical and attempts to align its spinning axis with the left vector only. So the spinning axis, if you see that if you see here that the spinning axis in left vector is there, no, so it will be aligned with that one only. So here it is been aligned with the vertical axis, and in roll with that rolling axis also it is there. So however, because of that aircraft in turn, the lift vector is rotating. That lift vector is when that lift vector due to that pitching axis, that lift is being generated. That is in a vertical direction. If it is rotating, the spinning axis of gyro is to align with itself with the lift vector only. So that is called the momentum vector. So that H stands for that momentum vector only. So that there the gyro must have the angular velocity, so which in turn requires a torque that has been applied to this one. So this torque will be developed by only the pitch misalignment only. So for this reason, that is it is required to able to cut out that erecting torque, during turns, when the aircraft is under control of autopilot only. Because when you are giving that angular velocity to that one, so the torque is being given to the pitching moment also. So that means when it is altitude is going on means it is getting pitching also. So at a time two things are there, then what will it happen? It will go to that it will go on misalignment only. Misalignment means at a time two movements have been given, so that it will coming on unstable condition also. So that is why it is desirable to able to cut out that erecting torque during the turns. When it is getting turn, or maybe that in yawing moment. So the aircraft is under control of autopilot only. So one method of accomplishing this is using that mercury switches in form of levels only. That mercury switches is what? So again, that like a this is like a this barometer reading only. So this mercury switches is what, for a small movement also this mercury will automatically get evacuated, so that it will operate the required control system. So if the rate gyro is erect, so the ball of mercury will lie on the center of that tube only. That a ball of mercury is there, no? So suppose if it is a tube and inside that ball is there, so that if it is center, if it is stable, then the ball will be lying on the center. If it is unstable, one side it will move. So if you see it on that for measuring the horizontalness of horizontal surface measurement also, we will see one indicator, water indicator will be there. That water indicator will be placed on that. So that water indicator only will see you. That water bubble will show you like where that bubble is stand still. If it is moving one side, that means that surface is not horizontal. So like that only here that mercury ball will be used. So the mercury ball will be lie on center, so that new erection signal will be generated. However, if the gyro is misaligned, the ball will be move on one end of tube, and that will close the circuit to an electromagnetic torque generator on the proper axis of erection only. So this must be done on both axes. Like if it is moving on one side, means that movement it will take. So that is around 1/8 degrees. So that is here it is there, no? So that is around 1/8 degrees. So 1/8 means what? Around 0.16 degrees, like that only, right? 0.16 0 point like that it will take. So I mean, I mean, uh, uh, so it will move at one end, so that close the circle, and that an electromagnetic torque will be generated at a proper axis of moment only. So, which is the with this type of erection scheme on the erection signal, that can be cut out at any time of heading command if it is fed up with the autopilot. So using this type of erection mechanism, that gyro can be made to indicate indicate the vertical to indicate to 1/8 degree. That is 1/8 degrees means same, that is 100 means 180. So 1 and 2 will be like 0.12 degrees, like that. So almost that it is important to as the gyro itself in determining the ultimate accuracy of that vertical gyro. In this type of in this type of pickup, it is important to make this arrangement should be very keen. So there are numerous types of pickups will be there. The pickups means early getting up. So some of the most common being synchros and resolvers and potentiometers and differential pressure pickups also will be there, because that movement sensor should be very accurate to take that movement. So that is why that synchros, resolvers and potentiometers will be used to take that instrumentation thing. So the ultimate choice depends upon the desired linearity and accuracy of the pickoff of signal, and the amount of torque, if any, produced by that pickoff only, like a signal generator, as it is sometimes generally called. So this is all about that vertical gyro as the basic altitude reference. Like for altitude reference, generally we are depending upon that vertical gyro vertical gyro instrument indication only. So that vertical gyro instrument also, how it is working depend upon that pitch and pitching angle and rolling angle axis also. We just show you now, and accordingly that how that autopilot is been generated, autopilot system is been generated, and how that instrument input it is taking. With that input, how that things are going on also, now we have seen. So to take this further thing, if you have any doubts with you, you can refer this textbook only. From starting classes, we have giving this textbook as a reference textbook only. So this is all about vertical gyro, vertical gyro attitude reference thing. So next class we will see further topics in this advancements in vertical gyro and pitch altitude advancements also we will see it on next video. So this is all about this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.